Hi, Mike Matchett with Small World Big Data. We are today talking about Kubernetes and one of my longtime favorite topics, performance testing, scale testing. How do we control and look for service levels, performance, just throughput, all those great things. We've talked about this through applications. We talked about it through infrastructure. Now we're going to talk about it through microservices and containers. So we've got Nate Lee with Speedscale here today. Welcome, Nate.
Hey, Mike, great to be here. Thanks.
So this is a great topic. I mean, we could go for hours on this, just warning you on this alone, just to even get into it. But you have brought with Speedscale this performance testing. I wouldn't even say performance testing, just all kinds of testing into the Kubernetes environment. So just start with telling us a little bit about what got you interested in the topic and how Speedscale got started.
Yeah, I had actually spent about a decade in the DevOps and testing space. Back in the day, my co-founders and I were part of a startup that did what's called service virtualization.
Mhm.
So that is basically mocking or simulating service endpoints back in the SOA days. And we've essentially adopted that concept to the Kubernetes infrastructure, right? Whenever there's kind of an influx of a new platform, there's bespoke tooling that needs to be developed. And due to the ephemeral nature of containers and IP addresses and networking and Kubernetes, a lot of these traditional test tools don't really scale. And so we went a step further and kind of invented this concept of traffic replay, where we use traffic as the base element to run these validations. So it's not testing per se; it's actually leveraging traffic to do the test, and from that traffic, we're auto-generating mocks and auto-generating tests that you can then kind of point at the workloads you need to exercise.
Okay, there's something hidden right there that I think we wish we could draw it on a whiteboard because it's pretty big, which is you capture traffic, but you're not just capturing traffic going into the system. You're capturing traffic going in and out to the backend services because Kubernetes containers don't work in an environment. It's a microservice mesh all the way through, like turtles all the way down.
Yeah.
So when you capture traffic, you're capturing traffic going in and traffic going out. And then when you replay it, you're replaying traffic coming in and replaying the service calls that would have gone out downstream and coming back. And that's what you're saying are mocks, right? So that's just for people who aren't up to date on testing terms. So you're kind of wrapping the system under test
That's right.
and replaying what's going in and what should be coming back in underneath them, so you can isolate that part and really get it going, which is pretty cool stuff. So how do you generally do that at a level of scale?
Yeah. So what we're doing is we're actually capturing the traffic using what's called a sidecar in Kubernetes terms.
Okay.
It's if you're not familiar, you can think of it as like a monitoring or agent, right? That you would drop onto the pod. This isn't a new concept. If you've heard of service mesh technology like Envoy or Istio, it's the same pattern that they're using. And so that the sidecars actually listen to traffic, and we have a DLP, data loss prevention engine, that actually filters any PII before we actually store that data. That data can then be perused and combed through to pick what sort of transactions you actually want to inject into your system under test as in the form of traffic replay, as well as what sort of transactions you need us to simulate in order to provide responsive backends. Because a lot of times, if you're just scripting and building test automation, the next problem you'll immediately run into is a lack of environments, right? And then once you get the environment problems figured out, the third problem you then run into is the proper test data. And I kind of call that the testing trifecta. You need the tests, you need the environments, you need the data in order to repeatably and reliably run any sort of quality automation. So we're handling all three of those problems just by leveraging the traffic.
Oh, which is a very g- cool, aggressive idea for people. I mean, they might not even have to write tests anymore if they can just grab traffic and just replay it and grab traffic at scale and replay arbitrary amounts of that traffic, which is pretty cool. Uh,
That's right. Yeah, we're trying to meet customers where they are. And so if they do have a big testing practice using something like Postman or K6 Grafana, we can actually take recorded traffic and turn them into Postman collections as well.
okay.
So they can actually augment and do what they're doing currently even faster.
Even faster. So before we dive into a little bit more of that, because there's a lot to get into here, what are some of the uses for this kind of traffic replay? What are some of the kinds of testing or kinds of uh, challenges or scenarios people are trying to use this traffic replay to solve?
Yeah, the most prevalent one that is our core use case is, of course, load testing. So
Mhm.
we're able to take that traffic and multiply it to higher scales. And that's pretty straightforward, right? But the key enabler is, again, the mocks, where we can stand in for backends that may not always be available, like third-party connections to things like Stripe and Twilio and payment providers. We have other customers that use us just explicitly for mocking, right? They've got connections to third parties that are only available in production type environments, and they need a simulator for that. A big one that's up and coming fast is what we're referring to as parity testing, but it's basically making sure that, hey, after I re-platform or after I merge together these two APIs, or after I move from EC2 to Kubernetes, I want to make sure that my application is going to fall over on day one when we go live. And so we can record traffic that normally enters our EC2 network at kind of an API gateway level, and then replay it again in their Kubernetes platform and make sure that performance is up to snuff. They're not getting any egregious errors. Their networking rules or routing as expected. And then the last use case that we see coming up as well is chaos testing or resiliency testing, however you want to refer to it nowadays. But once we record a baseline of traffic, there's all sorts of the stuff we can do with it. We can inject latency between calls. We can speed things up. We can, of course, multiply the numbers of traffic. We can even do things like simulate network black holes, inject 404s and 500s. And we're not capturing traffic at the TCP level, or sorry, Wireshark level. We're capturing actual API calls. So we're actually inserting those errors in the format of your schema, right? So it actually is in line with what you would see in a bad environment.
And we're talking about this. I can only think of some of the lessons I learned and the things I did as a performance guy for many years. And we started getting into capacity planning concerns as well and optimizing costs because you can do the what if kinds of things you were talking about there with the testing. Like, what if I have more users? What if I have more scale? What if I have another Black Friday? What if I add, some secret catalog offer and suddenly I've got 10,000 more
Yeah,
people showing up, right?
absolutely right. Yeah, that you've with regard to capacity planning, right sizing Kubernetes clusters and predicting headroom in terms of like CPU and memory. So we could install metrics servers and give you leading indicators of like, hey, this new update is going to, cause all sorts of CPU issues and take down, and those sorts of things will take down entire clusters. So um, preventing that sort of stuff. It's like getting a preview of what your app's going to do in production without any of the production risk, right? Because
Mhm.
using your users to test can have negative effects.
All right, so I know you can capture the API calls on a rolling basis. You can API this thing into all your CI/CD workflows with the testing and everything else. There's a lot of cool stuff there. But one of the things that I thought was really worth maybe exploring is how do you match the incoming service calls with the proper mock responses on the other side of this hamburger that you create, so that the stuff in the middle has a correlated possibility of actually working.
Yeah, this is probably the question we get the most because people are thinking through like the statefulness or persistent order IDs or customer IDs that need to be continuous or that persist throughout the test flow. And we've got a sophisticated way to actually parameterize unique IDs and moreover, things like timestamps and authentication tokens. And so as we're recording and capturing traffic, we're actually parameterizing key fields, and that's part of the IP of Speedscale. And so those values are actually able to get replaced real time when we're replaying traffic. You can't just take traffic from November 29th and replay it in June 10th. It's not going to work. The authentication is not going to work. The timestamps are going to be all wrong. So that's a minimum level of things that we had to do to actually make this a viable concept, and we carry it through to data persistence.
All right, so I can capture traffic from any time and then use that as a test at any time in the future as I go forward because you're doing this kind of transformation to keep the data relevant.
Right. Moreover, you can take traffic from a staging cluster and replay it in a development cluster, right? You can replay it in different clusters. A lot of people use Minikube or MicroK8s or K8s, kind Kubernetes locally on their desktops. You can take staging traffic or production traffic and replay it locally, which is shifting these production conditions really far left to do better testing.
I think people understand the benefit of testing to make sure things are going to function or perform. What are some of the other things that you've seen people getting out of this kind of ability to do testing on demand and testing on a recurring basis and scheduled testing?
Yeah, a huge benefit is that now that they have this data, now that they have this traffic, they're able to kind of dig into the message payloads that, of course, are PII redacted, and actually inspect what's going on with their application. A lot of times they don't understand
Mhm.
who their backend calls, or hey, this app was written years ago, nobody really understands, or I'm new to this team. So there's a level of API observability that we are providing by default, just by aggregating this traffic, and setting up these repeatable tests and mocks allow kind of an iterative opportunity. So you can actually have a control, which is a controlled environment. You can repeatedly test, and it's not like staging where people are constantly pushing new versions, broken versions of their code in, and you don't know if your tests are failing because of something you did wrong or the other people did wrong. So that iterative approach can be extended out to people testing different cloud environments. Google and Amazon are releasing new processor architectures and stuff like that. People are genuinely curious if there's capacity advantages to be had there. And Speedscale can also be used to kind of benchmark performance across different cloud providers as well.
All right, so you've got a lot going on there from the kind of the traditional views of what load testing can do down to some forensic analysis of what's going on in the API layer in the application, some traffic monitoring even I think can go on in there, and then you got this instant replay of traffic, live traffic into different environments, which is a really cool thing to be able to do is to be able to put portability. I guess we call it test portability on the
Yeah,
data.
that's a I like it. Yeah, that's a great name.
On there. Okay. Well, I think there's a lot more to talk about. You got traffic viewers, you've got a lot of SRE stuff, you've got some differentiation viewers, a lot of nuts and bolts to dig into. So I would just encourage anybody if they are in this Kubernetes area, they're doing any sort of development, even if you're IT and you're trying to support this, check out Speedscale. If they want to for more information, Nate, what would you have them go look at?
Yeah, we have an interactive demo at play.speedscale.com. So they can go to play.speedscale, check out the interface, how replays work, things like that. And if you think that's a good use case for where you work, you can actually go to speedscale.com and sign up for a free trial. There's a button there, and we've got a 14-day free trial. And if you need an extension, you can just shoot us a note.
All right, sounds great. It's some as a long-time capacity and performance management kind of guy from working lots of different places. I am just really excited to see some what people are doing like you guys in the Kubernetes space because it's the same in some respects of what we got to do. We got to make sure it works and functions, but it's very different when you talk about the speed and the scale and the location and all the other automated things we have to bring to the table today. So thank you for being here, Nate, and explaining some of that for us.
My pleasure. Thanks, Mike. Appreciate it.
All right, take care.